Okay, so setting up and solving differential equations, part 3. Obviously, you should have already watched part 2 and part 1. Now, we have seen that differential equations of the form this, so dy dx equals ky, so that's a directly proportional relationship here, have a general solution of the form y equals a times e to the kx. And you might say, well, what? We have seen that? Yeah, we have seen that. We did do a question that would have been very, very similar to that over maybe here. There it is. Dy dx equals y. And you end up with this e to the x minus e to the negative c, and then you finally end up with y equals a e to the x. Now that had a k value of 1, but if it had a k value of something else, it wouldn't be a times e to the x, it'd be a times e to the kx. So that's, you should be able to do it. If you want to work through that, if you want to solve that, you'll definitely get to here. Give it a try if you don't believe me. Now, you can read all this, but basically what they're saying is, yep, the solution to this is that, but sometimes it might be useful to rearrange it and write it as that. They can both be useful things, and then the reason this is useful down to the sort of the solving of this thing, because you can read all this, but it'll make more sense this way, I think. If x equals 0, we've got 1 on k log base e a y. So if for some initial condition x equals 0, let's say, then 1 on k can't be equal to 0. So that means that log base e a y would have to be equal to 0. And the only way that log base e something can be equal to 0 is if this part of it is equal to 1. So now we can say that ay is equal to 1. And if we knew what y was, let's say in the very beginning we were told that when x equals 0, y equals 200, then we would then know that 1 equals a times 200. That would mean that a is 1 over 200. So that's why being able to write something from this form in this form, because you can't really do that here, but you can do it very, very easily when it's in this form. Okay, so something to keep in mind, dy dx equals ky can be solved, or has a general solution of this, which is also this, which leads to some sneaky maths over here.